Hi guys, welcome back. Sorry about the delay in videos, but here we go. Algebra 1, lesson 73. We're on Saxon, 3rd edition, Algebra 1. We're going to talk today about factoring the difference of squares and probability without replacement. Two totally unrelated things, but are both part of this lesson. So what we're going to do first is factoring the difference of squares. We've talked a bit about factoring several different situations. This one is a really common one in that you have, the pattern is if you have something squared minus something squared, you will have x plus y, x minus y. So the way that works is if you have, for example, x squared minus 81, well, we know x squared minus 9 squared, which is 81, would give us x plus 9, x minus 9. Math is all about patterns, and this is just a pattern that repeats. So let's take a look at these example problems and see. Now, it's called factoring the difference of squares because the word difference means subtract. So you want to make sure that you have a subtraction problem. If you have an addition problem, not going to work unless we're talking about cubes, and then you're in Algebra 2, in Algebra 2, and we'll talk a little bit more about that. So this one, not a subtraction problem, but I can easily fix it to be a subtraction problem by switching things around. Now I have x squared minus 4. Perfect. What I have is something squared minus something squared. This step that I'm doing where I'm writing something squared minus something squared, I did it right here as well. You don't have to do that step, but the reason why I do it is just so you can see where I'm getting these numbers from. So this is going to be x plus 2, x minus 2. Excellent. Let's take a look at this one. Let's do that. Let's get it into something squared minus something squared. I think it'll be easier if we use parentheses on something like this. Now we know 7 squared gives us 49, and m squared gives us m squared. And we have a here. So we have something squared minus something squared. We get 7m minus a, 7m plus a. Awesome. Again, this is not a subtraction problem. This is an addition one, so we got to change it up a bit. 25y squared minus 36a squared. All those things are perfect squares, but I think it will help us if we write that down as a perfect square. By the way, this thing that I wrote up at the top, write that down. This thing right here, this is super important. Difference of squares. Write that down. Okay, so what we're going to have is something squared minus something squared equals 5y will give us 25y squared, and then 6a will give us 36a squared. So what we have is 5y minus 6a, 5y plus 6a. Excellent. All right, let's take a look at this next one we got right here. We have 40, again, this is not a subtraction problem, but we can turn it into one. We've got 49a squared minus 36x 6y4. Now this one's going to be a little bit trickier. I'm going to write a little bigger just so you can see it. Something squared minus something squared. Let's go ahead and we're sort of doing like factoring a reverse distribution, right? So we know this is going to be 7a because that squared would go to 7 and give us 49. Go to a, it would give us a squared. Over here we have 6, and then we have a to the third y squared, because if I distribute that 2 to the third, I would get 6. Remember, we multiply when our exponents look like that. So, and then the same here, if I distributed this to here, we would multiply and get 4. So this guy up here, all we have to factor it into is 7a minus 6x3y2, and then 7a plus, let's see if I can get that in there, 6x3y2. So that is the difference of squares. That's how you would do those guys. Let's talk about now probability. Like that word is hard. No idea. Okay, so we're gonna talk about probability with and without replacement. The most common way that you will see this is you have a bag of marbles and 4 of them are red and 5 of them are black. What are your chances of pulling a red one? That's exactly what we're gonna start with, okay? You have a bag of marbles, it's 3 black ones, 5 white ones. What are the chances that you draw 2 of them with replacement and make it black? Well, the first one, normal probability says favorable outcomes over total possible outcomes. So the total possible outcomes, if you reach into this bag, you would have 8 marbles to choose from, okay? So you'd have 8, and then the chances of it being black would be 5. Now, you put that back in, and you want to try it again, you're going to do the same thing, but you're going to multiply. So it's going to be the second time, now you've put everything back, it's just repeating itself. We've got 8 marbles in the bag, and then we reach in, and there's 5 possible chances of getting black. So the chances of us doing that in a row, we have to multiply. So we get 25 over 64. That would be our answer here, okay? Now, let's say we do this without replacement, In that first one, we have 5 out of 8 because there's 8 possible and 5 would make it black. Now, we take that black one out and we set it aside. There are now only 7 in the bag and only 4 of them are black because we set one off to the side. So our answer here is going to be 20 over 56. Of course, we can reduce that down. And so we get 10 over 25, 6, 7, 8, 28. Then cut them in half again, we get 5 over 14. So the chances of that happening would be 5 out of 14, as opposed to the 25 out of 64. Okay, so let's see about the next one. All right, you guys, I just looked at this and I'm like, I just did this for white, y'all. I did 5 would be white. The answer is, or the question is black. So I had to pause that and figure that out. So if this was a white, this would be the answers, but let's actually use the black now. So we know that there are 8, and then the total possible black would be 3. So we do 3, and then again, 3 times 8, which would give us 9 over 64. So that would be a much more accurate answer if we're talking about black and not white. Sorry about that, guys. So we come back over here and we look at it, and 8 here, we have 3 black. Now, again, we're gonna pull that out. We only have 7 remaining, and if one of them is black, we only have 2 black now. So we have, and I think it's easier to cross cancel before we do anything. So if I divide this by 2, I get 1, divide this by 2, I get 4. So I get 3 out of 28. I'm so sorry I misread that, folks, but this is black. Black, right there. White, right there. Okay, so now let's try that again, but this time I actually read correctly. So for the next example, we have 4 red, 7 blue. 4 red, 7 blue. With replacement, we want first a red and then the second one to be blue. So in our urn, we have 11 marbles. 11 marbles, okay? With the first one we're gonna be is red. Now I'm all doubting myself. The first one is gonna be red. Well, the possibility of that is 4. Now we replace that one back in, and now we want a blue. Again, it's gonna be 11 that are in there, but the blue is gonna be 7. So in this case, we get 28 over 121. Now let's talk about if that was without replacement. The first chance of it being red would be, again, 4 out of 11. And then with replacement, so now we have taken, without replacement, we have taken one of those out of there. So now there's only 10 in there, and it was red that we took out, so there's still 7 blue left. And then we multiply straight across, we get 28. Actually, again, I think it's easier if we cross cancel first. So divide this by 2, I get 2. Divide this by 2, I get 5. So we get 14 over 55. 14 over 55. Okay, guys, so, and that's what happens when you actually read the colors correctly. I don't know. Okay, so the practice problems, let's take a look at that. Okay, so take a look at these practice problems. Here's the first part. Here's the second part. Go ahead and pause the video, do those, come on back and see if you got them right. So in this case right here, we would have 8x squared minus 9y squared. That would give us 8x minus 9y, 8x plus 9y. So this would be our answer right here. For this guy, it's not a subtraction problem, so we gotta fix that. So it's gonna be 100m squared minus 25. That gives us 10m squared minus 5 squared. So we end up with 10m minus 5, 10m plus 5. Like that. Okay, let's do this next one. We've got something squared minus something squared. So we have y squared, because y squared will give me y to the 4th, and then just x, because x to the 1 times squared would give us that. 13z to the 5th, because 5 times 2 would give me 10. So that reduces down to y2x minus 13z5, y2x plus 13z to the 5th. Now, again, your pluses and your minuses and your plus here, those can be in any order. You can have the plus first or the minus first, doesn't matter. Let's talk about this guy. So we have 4 purple, 3 pink. We want to draw both purple with replacement. So starting out, we have 7 possible, and 4 of those would be purple. Now we replace that back in, and again, we have 7 there, and we want to do purple again. That's going to be 4 out of 7, which gives me 16 out of 49. Okay, so then without replacement, this would be 7, and we want to do purple, which is 4, times, now we have taken out that purple one, which means we only have 6 here, and the purple, there's only 3 of them now. 3, okay? I'm going to reduce this guy down to 1/2, and that would give me 4 over 14, which again I can reduce and get 2 over 7. 2 over 7. Let me make sure I did that right. Looks like both purple. Good. Okay, so for E, you have 5 orange, 6 blue, first orange, second blue. For the first one, we have, that's going to be 11 here, and we want to do orange, which is going to be 5. Now we replace it back in the bag, which means there's still 11 there, and we want to do blue, which is going to be 6. So we end up with, 30 over 121. 30 over 121. Now let's do it without replacing. The first thing that we're going to do is we will do 11, and we want to do orange first, which is 5. And now we've taken that out, and so we've got an orange one missing, which means now we only have 10, but there's still 6 blues in there. 6 blues. Let's cancel these out. That'll be a 2. This will be a 1. And then here I can cancel this 2 out, make that a 1, and make this a 3. So 1 times 3 is 3. 11 times 1 is 11. So that would be your answer. All right, guys, if you have any questions, let me know. Otherwise, that is the short of it. Excellent work. Thank you so much.